Hello and welcome to this Python tutorial. So in the previous tutorials we did the main part of natural language processing because we created our bag of words model, which led us to this sparse matrix of features X that is nothing else than the matrix of independent variables, which contains 1500 columns. And also, right after we created this sparse matrix of features, we also created our dependent variable vector y, this one right here, which contains the outcome of the review, whether it is positive or negative. So for each review, 1 means that it's positive and 0 means that it's negative. And so now we have exactly what we had in part 3 classification, that is, we have a matrix of independent variable x here that contains 1500 independent variables, so a lot more than we used to have in part 3, but that's very common in data science, so we will perfectly be able to build a machine learning model out of this. And so each line here corresponds to one specific review, and for each of those reviews, well, each of the column corresponds to one word, and we get a 0 if the word doesn't appear in the review, and a 1 if the word appears in the review. And so basically that gives us a classification model, because now we will train a machine learning model that will try to understand the correlations between the presence of the words in the reviews and the outcome, 0 if it's a negative review and 1 if it's a positive review. So that's the first thing to understand here. And now the second thing to notice is that indeed we have a lot of zeros here, because for most of the reviews, most of the words don't appear in the review, so we have a lot of zeros, and that's what's called sparsity. And we have two ways of dealing with sparsity, that is, trying to reduce it. It's by filtering more words here thanks to this max features parameter. So by reducing the number of most frequent words, we can reduce it to 1000, for example. And the second way to reduce sparsity is through dimensionality reduction, which we will treat in part 9. So we will learn these techniques later, and right now we are about to make our machine learning model. So let's close this and let's do it. So now this is basically the exciting and comfortable step, because we basically did all the job. And why is that? It's because we already have our matrix of features, which is this sparse matrix here, and our dependent variable vector. So now what we only need to do, and you'll see how we do it very efficiently, we just need to do some copy-paste of our machine learning classification models that we built in part 3. So let's do it right now. Let's do it very efficiently. You'll see how we are already ready to make the models. So we'll go to File Explorer here, and we will go back to part 3 classification, because that's where all our classification models are. Here they are. So let's see what we have. We have logistic regression, KNN, SVM, kernel SVM, naive Bayes, decision tree classification, and random forest classification. So which one to choose? Which one would be the best for natural language processing? Well, we have two options here. Since we already have our matrix of features and our dependent variable vector, and since everything is well prepared for our machine learning classification models, well, what we can do is test each one of them very quickly, and then look at the accuracy, the number of false positive, false negatives, and look at other performance criteria to decide what would be the best model. But if we don't want to do that, well, we must know that in general, based on experience, based on experiments, well, the most common models used for natural language processing are naive Bayes and decision tree or random forest classification. That's the common models we use for natural language processing. So that's what we'll use right now. And in this tutorial, we will try naive Bayes. So let's do it. Let's do it very efficiently. You'll see how it's going to be so simple now. So naive Bayes, and let's double click on this naivebayes.py Python file, because that's where the model is built. So here we go, naive Bayes. all good. And now you'll see how everything is going to be so simple. As I just told you, everything is well prepared. You know, we called our matrix of features, that is our matrix of independent variables, x, and then our dependent variable vector, y. So everything is all good. So basically what we need to do is to just take this from here to actually here, because we don't need the visualizing part, because, you know, this is only for the case we have two independent variables to be able to show the prediction regions and the prediction boundary. So of course we can't use it because we have 1,500 variables. If any one of you finds a way to represent a plot in 1,500 dimensions, please tell me. But for our problem, the visualization part will consist of looking at the confusion matrix to have a look at the number of correct predictions and incorrect predictions. Okay, so basically we only need that. So we will copy this and let's go back to our natural language processing code and let's paste it here. All right, and now, as I told you, we don't need to change anything because indeed we have our sparse matrix of features, that is our matrix of independent variables, which is called X here, as well as here in this code section to create the training set and the test set. Then we have our dependent variable vector y, which we also call y here to create the training set and the test set. Same thing. And basically, since x and y are in some way the only input to train a machine learning model, you know, we could transform this in some kind of function. And if we do this, the only inputs of the function would be x and y. So that means that we have everything we need and we can just select all this to train the model and test its predictive power on the test set, to then look at the confusion matrix to see the number of correct predictions and the number of errors. All right, so basically we are ready, but it might be better to remove this section because we don't really need to apply feature scaling here because, you know, we have mostly zeros, a few ones, and a very few twos or threes. So feature scaling is unnecessary here. And the second thing is that, you know, since we have 1,000 observations, we would like to have the maximum observations to train our machine learning classification model. And right now we have 25% going to the test set, which means we'll have 750 observations to train the classification model and 250 observations to test it. So we would rather have more observations to train the model and fewer observations to test it. So maybe we'll pick 0.20, 20%, so that we have 800 observations to train the model and 200 observations to test it. So right now we're good. We are ready for the ultimate step, that is making the whole model. So if you want, just for fun, we can reset everything by restarting the kernel here. Yes, all right. So it's connecting to a new kernel, here we go. And now I will just select everything up to the top, go to Variable Explorer to prepare what we're about to see, and basically press Command or Control plus Enter to execute the whole code. All right, and now let's have a look at the confusion matrix. It's CM here. Here it is. So this confusion matrix gathers all the correct predictions and incorrect predictions of all the reviews in the test set. That contains 200 reviews. And what do we see here? Well, we see that our machine learning model made 55 correct predictions of negative reviews, 91 correct predictions of positive reviews, then 42 incorrect predictions of positive reviews, and 12 incorrect predictions of negative reviews. Okay, so that means that out of 200 reviews, our machine learning model made 55 plus 91 equals 146 correct predictions, and 42 plus 12 equals 54 incorrect predictions. So since we only had 800 reviews to train the model, that's actually not bad. You know, if we had 1 million reviews, we would get much less incorrect predictions because simply our naive Bayes model would find more and stronger correlations between the cleaned text reviews and the outcome. But here, by training the model on only 800 reviews, this is actually not bad. And let's have a look at the accuracy for this. Let's compute it here. All right, so the accuracy is the total number of correct predictions, that is 55 plus 91, then divided by the total number of predictions in the test set, that is 200, because we have a test size of 20%, which out of 1000 is 200. All right, so let's select this and press Command and Control plus Enter to execute. And that's the accuracy, and we get 73%. So that's actually not bad at all for this small number of reviews. Alright, so that's the end of natural language processing in Python. Congratulations for having completed all this, creating the Bag-O-Words model, training a classification model in this dataset. But that's not the end of your natural language processing journey, because right after this video you'll get a little challenge. So I will let you find out about that, and until then,